Hey, welcome back to Diode Press. Today, we're going to be doing a review of the Creality Falcon 2 Pro laser. This is a 40-watt machine. And we're going to look at a couple ways you can use a machine like this in an art studio setting. Let's get to it. So I guess one of the first questions is, why would you need a laser cutter in an art studio or a print shop in my case? And it's one of those tools, but once you have one, you just find a ton of uses for it. So real quickly, a couple things I use my laser cutters for. So I make holders for my ink brayers, cut out of wood. They hold all these safely out of the way. I use them for packaging for products that I sell. And for this, I just use scrap cardboard from deliveries and whatnot, cut out the shapes, do my engraving, and it's reusing old packaging. I've made a lot of projects using wood and then engraving an image directly onto this, and then printing this just like you would a woodblock print or a lino cut print. And I also used it to make a print block to use for packaging. So I ink this up and print it on my shipping envelopes, and it's a nice, easy way to get all your branding on there. I've used it in the past to make different kind of jigs that I use for gluing things up. Or one of the most probably complicated projects is creating a printmaking paper rack to dry prints on. So it has marbles inside. The paper locks into the marbles, and then when it's dry, you let it take it out. And these are modular, so you can add links together. And so this was all cut out on laser cutters and then assembled afterwards. So that's just a couple of the projects. I mean, even looking at my desk here, this whole organizer was cut on the laser cutter. The ink racks on the wall, these are all designed and cut out on a laser. So really, it's endless possibilities. So let's talk about this machine. So it's a Creality Falcon 2 Pro 40-watt laser. So Creality reached out to me. They sent me an email and asked if I had any interest in reviewing this machine. And I said, absolutely. I love using lasers, and I'd love to check it out. They're not paying me for my review, and they have no say over what's in the video. So this is just my honest opinion and setup of the machine. Let's jump into the unboxing. So I'm not going to go through all the steps of unboxing it. It has a pretty thorough instruction manual. There's a lot of videos online describing all the processes on how to put it together. I'd say from start to finish, it took me 45 minutes to an hour to go from a closed box to my first cuts. And so what separates this from some of my other machines that I've used is it has a built-in enclosure. So all my machines have enclosures of their own just for safety, but this one has a built-in. So you assemble the rails, screw on these red panels, and then the machine is fully enclosed, and if you open the door, it shuts off. So the machine they sent me has a 40-watt laser module. And a 40-watt module is great for cutting thicker materials or cutting things really fast. But the higher the wattage of laser, it tends to have a thicker beam. I mean, it's still very thin, but they also send the smaller laser more for engraving type of work. And this is a 1.6 watt. So I haven't tested this one out, but I imagine this is good for just light engraving work, where you're not needing to cut through anything, but it's going to have a really tiny focused beam to get really high detailed engravings. It also came with this box, which had a couple USB drives with software. And then it has extra lenses, tools, Velcro, little kit of stuff. And this machine has a built-in camera on top. And so there's a whole calibration guide to set that camera up, which I've never had a camera before in a laser. And it's really helpful for making cuts go really easy. So it comes with this calibration card you have to go through and a piece of wood to do the testing on. So I'm still figuring out where I'm going to put this machine. It's going to replace my main workhorse laser that I'm using. And so I'm going to build its own stand and kind of spot for it to go. So today it's just on my CNC machine table. So a couple key features. Control panel has an emergency stop button, which is nice. Has a key. So you can turn it off, take the key out. And that's nice. I have two small kids. And so keeps them from messing with it and just an extra level of safety. And then it has this sliding enclosure. And so when this door is open, the laser won't work. Once you close it, it has a latching sensor, I guess. Then it'll work, the lights turn on, and if you open it mid-cut, it just stopped. And on the laser itself, it has some sensors here to tell you if it needs more air, if there's a fire in the machine, or if the lens gets dirty. And then over on the side, comes with a small air compressor, and that's controlled from the software, and it plugs right into the side of the machine. And there's a small dial here you can turn up and down to increase or decrease the flow. If we jump over to the back here, it has a built-in fan, and it came with a short hose. Right now I have a long hose connected to go out the window, but that fan kicks on either automatically or you can make it on by default. And that does a really good job extracting out the fumes and keeping your place clear of any smoke. Because if you're cutting any kind of woods or plastic, you definitely need to be venting it outside. You don't want to breathe that stuff in. So we'll quickly look inside the machine. So it has these slat rails that fit inside these grooves on the side, and that keeps your material off of the bottom. So when the laser's cutting, you don't get a lot of flashback on the back of your material. It works just like a honeycomb plate you would see on some lasers. The only downside to this is some small pieces can fall through, but that's not really a problem because this machine has a drawer that you can pull out. And so as you're cutting, if the pieces fall out, you can pick them up from underneath. The only concern or downside to that is if a small piece falls through and then you're cutting something else close to it, if it falls under the path, it can get hit by the laser underneath. But so far, I haven't had much of an issue with that. And you could always put a honeycomb bed on top of this if you wanted. And these slat rails, you can take them out. It looks like there's like one for every other slot along the side. And in the center section here, you can take these and lay them flat. And that gives you a nice flat surface to work with. And then underneath here in this center section, there's a small camera. And so inside your software, you can use that camera to see the bed of the laser and align your materials. And it's just a really nice feature to have, especially to not waste much material. And I'll show you that in a minute. So every laser I've used has a different way to set the material height. So the laser, depending on what you're using, has to be an exact set distance from the material to the end of the laser beam. So if you're too close or too far, you'll either get too wide of a cut, won't cut all the way through, etc. So this machine comes with a small calibration block, and each level is for a different material. So 6mm and greater is the bottom, and then engraving or cutting basswood 1 to 3mm, which is assuming what this is. And so you just set the block there, lower these 2 set screws down, let the front of this enclosure touch the plate, and now it's set for the height for this particular material, and it'll cut through this no problem. And a 40-watt laser can cut through some pretty thick material, and it can cut through thin material really fast, which is really what you want, because if you're cutting fast, it's making less soot and smoke along the edge of your cuts. So even if you don't need to cut thick material, being able to cut it really fast is helpful. And so now let's quickly jump over to the software I'm using to control this whole setup. So the software I'm using is Lightburn. I want to say it was like $60 or something one time to buy it, and it's definitely worth it. Probably better than the free versions of different programs out there. And so once you get it installed to set up their laser, you just add a new device, and it comes with a file that you import, and it sets up the bed size and all the settings and all that stuff. It's just a couple clicks. And then for the camera, there was a whole process to set up the camera. And it came with a couple calibration card steps. And basically in Lightburn, there's a whole procedure you go through of putting a grid, this calibration grid on 4 corners of your machine, and it takes a picture and calibrates it. So it took about 20 minutes, but it was easy to do. And now that that's there, I can hit update overlay, and it shows me the bed of the machine and the piece of scrap wood that I have sitting in there to cut. And without the camera, you kind of have to measure or guess or estimate where things are. Once you get the camera set up, now I know I can put this image that I'm going to cut right in here, and it fits within the bed of the laser, and it fits on that piece of material. And so you can really use up every piece of scrap you have and not have much waste. So this file, this is the ink brayer file that I sell. I sell these flat packed. And so I use the outline as the total piece that I ship out. It cuts out a small piece here where I put screws for mounting it. And then these 3 pieces are the actual holder for the ink rollers. And you just put a drop of glue and they fit together. And then this in here is an image that goes from white to black. And so as it cuts this out, it makes a countersink for the screw. So the wood screw fits right in there as a countersink. Basically, as it hits the white, it barely cuts. And as it hits the black, it cuts deeper. So you get a nice like 45-degree bevel. And then the red outline is the actual cutting. And so we'll set one of these up and give it a cut, and I'll show you what that looks like. So here's the bed of the laser with that piece of wood in there. And so you just loosen the set screws. So this is 5mm birch. And so I'm going to set this to, it has a 4 to 6 millimeter step. So that's that middle step right here. So I'll set that for the height. And it kind of drops down a tiny bit when you pull this out because everything flexes a bit, but it just has to be close. And now we're ready to go ahead and start the machine. So the first step is going to be just to close the enclosure because it won't run without this closed. And over here on the machine, on the screen, I'm going to home the machine. And so this tab over here shows you all the different layers in this file. So the text here is going at, I'm working in millimeters a minute. So 6,000 millimeters a minute at 25% power. That should be good. This is the countersink holes, the image. So it ranges from 30% power for the white areas to 80% power. I'm actually going to bump that down a bit. This is all set up for a lower wattage laser. And this is the cut. So I'm running at 700 millimeters a minute at 100% power. So I found you want to run things fast and high power so you get a cleaner cut that doesn't have time to burn versus a slower speed and a lower power. It's better just to have less time in the cut. You get a better result. So that's it. You just select your artwork, hit start. And so while that's cutting, I'll show you over here. So you have your fan. This is the exhaust fan, speed up and down. And then this dial here is to adjust the air pump volume. So I have it turned all the way up. You can turn that down depending on what you're trying to do. And here you can see it's doing the cuts of the individual pieces. And you can see that smoke being pulled out. So here's the final piece off the laser. You know, a little bit of smoke here. You could mask this off with tape first if you wanted, but I just hit it with some sandpaper. So these pieces, you just push them out. And depending on the wood you use, the moisture in the air, moisture in the wood, your speeds may vary a little bit. But so far I found between 600 and 700 millimeters a minute works pretty good for this material. Cleans that up. These look good. And this is just for shipping. So it doesn't really matter. I usually clean it up just to ship out something that looks presentable. But that looks pretty good. And so when I mail this out, I usually glue on a piece of paper on the back and cut it out. And all the pieces fit inside there. And this just goes in an envelope for shipping. And then once you get it, there's a couple screws in here. And when you design things for the laser that gets assembled by someone, it's nice to make it so you can't put it together the wrong way. So these tabs, one is smaller than the other, so it only fits in there one way. The other one only fits there this way. And there you have it. And then if you look here, there's two screw holes. There's a small countersink, so the head of the screw sits flush with the front here. And so a couple dabs of glue or super glue, and then you're ready to hang it up on the wall. So let's talk about some pros and cons of using a laser cutter for art or as an artist. So let's start off with this example. So I made this so I could make packaging. So I take this, I ink it up, put my envelopes on it, run it through the press. I could have spent, the hours it takes to carve out each one of these individually. I have the tools, I have the skill to do it. It would take a lot of time. And I've spent 20, 40, 60 hours on a print block before. But this is just for packaging. I don't want to spend that time on there. But I didn't want to have to pay a company to send me pre-printed envelopes. I have the equipment, I have a printing press and a laser cutter. So it's a great use for that. And some people have a concern about losing the handmade aspect of art using tools like lasers or CNCs or 3D printers. This is a 4-color CMYK woodblock print. And so this is all made on a laser cutter. And this image was drawn on an iPad, sent to a laser cutter. Each block was cut out, and then each one was printed individually for a final print. So this is one of the proofs of that project. And sure, I could do something similar with a woodblock print, but this is a lot just like making a screen for a screen print. You take your artwork, you expose it onto a screen, then you print each one. I would say it has its place. You can do some really creative things with a laser cutter. you do lose some of that hand carved or hand cut, mistakes or things that happen when you're carving a print block. By using a laser, you get exactly what you put in the machine essentially. But I don't see a problem with that. If you want to get out your lino cut tools or wood cut tools and carve an image, you're free to do that too. And I have a lot of videos on my channel going through that whole process. So it's fun to look at different equipment and different ways to do things. And I have to say, using recycled cardboard and laser cutting out the shape and putting in the text, this is 100% recycled material that was already recycled material. So everything I'm shipping out is, has been used or used a couple times at this point. It's a good way to get rid of your scraps, and so you can use it for packaging or, things like that. And if you have an idea for a product like this print drying rack, prototyping on a laser cutter is a great way to go, because material you can prototype in, MDF wood or even cardboard for some mock-ups or cheap plywood before you get into, some of your nicer plywoods. The barrier to entry is much lower. So for this one, I went through probably dozens and dozens of prototypes before I had the perfect print drying rack. Now I'm going to have this option, and now I'm moving on to a more polished CNC made version. But this one's out of cherry. So to prototype this out of cherry, this is a $30 piece of wood. If you mess it up, you're out that piece of wood. Whereas if you're testing this in cardboard or MDF, you're out just a piece of MDF. So it definitely has a really strong place for product creation and prototyping. So before we wrap up, let's talk a little bit about materials. So down here in my storage drawer, I have a couple different materials I use preliminary. So I have some MDF, which is just thin panels of MDF. This is great for quick prototyping, cutting out. You can use this for production stuff too, if it works for your application. I use this 5mm birch from Home Depot. It's pretty economical. It's always available. On Etsy, I found some different materials, 6mm, which would be fine on this machine, maybe a bit thick for some smaller machines. And then all of my printmaking registration jigs are cut out of acrylic. So it's the sheeted green acrylic. And so by nature, a diode laser can only cut certain materials. It can't cut clear because it needs, whatever the science behind it, it needs a opaque surface to be able to cut. And so green, it's a blue laser. So green acrylic cuts like butter. It's quick, nice clean cuts, no problem. Red's great. Most opaque colors are fine. If you get into more of the translucent colors, some of the glitters, things like that, you might start to have trouble. So definitely look at the materials you want to cut and make sure that a diode laser is able to cut it before you buy it. Here's one of the registration jigs, right off the machine. It has really good detail. All the numbers are easy to read. And it came out perfect. And then when it's time to ship it off, fits right in there. A couple pieces of tape, goes in an envelope, good to go. Well, I figure while we're here, we might as well try out this other laser module, see what it's all about. So the old one just plugs right in. A little bit of Velcro. Here's the air assist line. Comes off, and there's a little cap to protect that hole so you don't get dust in there. The whole module slides right off. So I've never used a laser this small, so 1.6 watt. Just a little guy. And it does say you can hot swap them, so you gotta turn the machine off, unplug it, plug in the new one. So we'll just follow that. And I think we're good to go. So let's give it a test. All right, so here they are off the laser. So this was cut with a 40 watt module. I really like how it makes it like a white. It's obviously much stronger and thicker, which is kind of what I want for this product. Makes it easier to see, easier to read. When you go to line up your paper to make your prints, it's really easy to see where the line is. Here you can see what the 1.6 watt laser does. So it's a significantly smaller line or kerf to the laser beam itself. It's deep, you can feel it, but it's just super fine and detailed. Doesn't really show up much on acrylic, or at least this color. So I ran some tests on wood. So using that same power on acrylic on wood, obviously too dark. A little bit too dark. I think this one's about right, one of these two.
just in the interest of being thorough with this laser. So within Lightburn, you can do laser level testing in there. And so you just set up the speed and the power that you want to use. And so 10% power really doesn't show at all. 30% shows pretty good at slower speed. 100% power, somewhere around 800 millimeters a minute. Really nice crisp lines. That's probably the setting I would use if I was trying to do some really nice detail work. So you can do the same kind of testing with the 40 watt or any other laser. So definitely something you want to do with each kind of material you get. Test out the materials, see what speeds and power levels work best. Same thing with the engraving. If you want to fill in areas, you can see what speed and power works best. No laser cutting video is complete without the obligatory thick piece of wood being cut. So this looks to be about 3/4 inch wood. This is poplar. And at 175 millimeters a minute at 100% power, you just blast it through that with really no issues whatsoever. And one quick tip, you can buy these on Amazon. They're kind of like a metal bristle brushes. These work great for taking the soot off of laser cut pieces. Does a really good job cleaning them up. Let me know down in the comments if you have any questions or you want to see different things demonstrated. I'd be happy to do that. And I will see you in the next video. Thanks.
Thanks for watching. To keep up with the videos when they're posted, make sure to subscribe to the channel. And if you want to help support this channel, you can check out the Diode Press Patreon page, where I post behind the scenes photos as well as other patron rewards. Thanks!